Hello, everybody. I don't know how you're feeling. I'm a bit tired because my daughter decided to make a party tonight. So you do look a little bit also like you have like a long night. Maybe we do start with some stretching. I think this is always good at the beginning of a talk. Before we start, my name is Christiane Miethge. I work at Infineon in the AI and data team. I have the responsibility there to lead what we call the Responsible AI Office. Who are we? We are a team of cross-functional experts that together designed a governance framework to really make sure that the AI system that we built internally at Infineon or that we license or purchase from external are trustworthy and responsible. I can tell you in a bit what this means, but the focus will be today on sustainable AI, and I want to start with the bigger picture. Which direction do I have to point to make this work? Now we can. Cars that can feel, assist, and protect you. Consumer devices that can intuitively understand and support your ideas. Robots that can automate tasks such as assembly line work with greater precision and speed. AI is changing the world as we know it. It enables innovation, it allows new use cases for companies and also for society. It boosts efficiency and improves decision making. In other words, it changes the way we work, the way we live, and the way we interact. However, this comes at a price. And I think you probably have seen some of those numbers already, but I think we always have to repeat them because they're important. If you look at the power demand of an single AI data center, it equals roughly the power of 3 million homes. And it's not just about the electricity, right? Also take water. The water withdrawals due to AI by 2027 is estimated to be 2 million. This is roughly the same of 2 million Olympic swimming pools. So just imagine this, 2 million Olympic swimming pools is the water that will be needed. And this is not only because of the training. At the beginning of this AI boom, we spoke a lot about, those models are so big, the trainings, the costs are so big. But now we've reached the point that inference, actually, when all of us are using those AI systems, and the companies are using AI systems, all this inference equals, like 1 week inference of GPT-3 equals 3 times the energy demand of the training. So inference is the bigger problem now in terms of energy consumption. And this is because if we pose one question to ChatGPT, that's 10 times the energy of a Google search. So it's not just quickly asking, it is 10 times the energy. And of course, if you ask for generation of an image, it will be more. And this leads us to an increase of compute drive by AI. Right now, we are roughly at 2% of global electricity consumption. And the estimations are that we will reach by 2030 7% of global electricity consumption. So that equals the energy consumption of India today. I remember when I first started to look into these figures, we were like at AI is roughly the energy consumption of Luxembourg, then it was Netherlands, and now we're getting bigger and bigger with the countries until like India, which is one of the biggest, most densely populated countries in the world, right? So what can we do about it? So what Infineon is doing, we drive a sustainable AI in 3 fields. I would like to start with the middle. We power AI, so this means we supply specific energy-efficient hardware for the data centers of the future. I'm going to tell you a little more about this in a second. We enable AI, so we specialize on what is called edge AI. So those are extremely small, energy-efficient models at the edge. I'm also going to tell you more about this. And we use AI, of course, to boost our efficiency. All companies are doing this now, that we have to. But also for efficiently produced sustainable products to really improve the sustainability of our processes itself. So let's start with we power AI, right? What we do is we power AI from grid to core. That really means there's Infineon hardware in all of those animals, from the solid-state transformer to uninterruptible power supply to solid-state circuit breaker to the core of the data centers, the data center server racks, and then the heating, ventilation, and air conditioning, right? So this is the more technical point of view. Don't worry, you don't need to get the details. I think what I just wanted to tell you, especially if you don't come from the semiconductor industry, right? Maybe for a lot of people, semiconductor is a chip and it's probably the same. And NVIDIA is doing the same like Infineon, but this is really not the case. So the AI training, the chips that are really used for AI training, this is NVIDIA territory. What we are Infineon doing is something else. Really specialize on very small chips that can do exactly the tasks they're asked to. They're not the super brains that can do everything and then also cost a lot of energy. They're really, really focused and specialized. And because we specialize on this, we are able to provide parts to a data center that makes it a lot more energy and resource efficient. And NVIDIA, for instance, is the customer from us in this context. So if all data centers in the whole world would use Infineon hardware, we could save 22 million metric tons of CO2 yearly. And this is also calculated really with the total cost of ownership, right, from the beginning, from the production till the end, implementation in the actual data center. This was the power part. Now let me come to the enable part. So this is really when we are not just using AI or providing hardware for AI, it's really when we enable our customers to produce AI on our chips. So you can think about, you have a chip, and on top of this, you have a layer of software. And this software can entail AI, right? And we have a tool set where our customers can build the AI system on our hardware. We have specialized hardware for this. Or we even provide pre-trained models directly to our customers, right? And this is AI at the edge. We do this in automotive, in IoT, and in industrial applications. And because those models have to fit on a chip, and you can imagine it's like you, I'm sure you have seen these pictures of chips. They're really, really small. And these models by default have to be very, very small. So our data scientists are specialized on producing really, really tiny models. And the whole movement even started, at the beginning it was called Tiny ML. Now we're moving more to general AGI, or sometimes I've also heard the word of tiny LLMs, and so on. And the advantages here are, because those chips then go into any device, right? It could go into any device you have with you, it could go into a robot, and so on. The AI can operate on top of that, so there's no internet connection required. There's real-time decision-making. There's no back and forth between the cloud. The kind of decision can come instantly, and because of this, it's also much more energy efficient. It's much more reliable, and there's improved security and data privacy because, of course, the data stays on the device itself. It doesn't go to the cloud. And sometimes there's even no cloud connection if it's not wanted. Sometimes there is for updates. It really depends on the use case. So what are some of the use cases we have here in this field? One, for instance, this is the example from automotive, and I just want to focus on the one that is like in green here. This is battery management, right? So if you take an electrical vehicle now, you have a battery in there. And usually what has been done in the past was that the engineer said, well, I think roughly by experience the battery can last this long. But there was no real data. And now what we can do is, with specialized sensors and with our hardware in those batteries, you can measure exactly the state of health of this battery and can immediately also foresee how long will this battery still last, which then allows you to, with much more precision, say, okay, I know this battery is still going to last this long. And this then increases the battery life and almost double the vehicle range. Yeah, you can really use an electrical car for much longer than you could without this edge AI technology. And now, I was already told you, we are now moving not only from tiny ML, we're moving to the tiny small language models at the edge. So if you really take an edge AI system, so I said we have specialized hardware, one of this would be called, for instance, the PSOC edge. And then you take a generative AI language model or large language model. And then you, of course, if you just take GPT, whatever, 3, 4, well, as it is, it would not fit on a chip. It would be just too big. But then what our engineers did, they made it small. They looked which parameters do we need. There are special techniques you can do to make it smaller. So it could eventually fit on a chip. And then, of course, this would not be for all use cases, but there are a lot of use cases where this is extremely relevant. So you take a smartwatch, right? You can use it for running. You want to ask questions like, how should I start my 10 minutes warm-up, right? You want to get maybe workout recommendations. What you probably don't want your watch to do in this instance is calculate a complex math task, right? This you can do on your computer. You don't need this on your watch. Same is on your washing machine. You can say, well, why is the cycle not starting? Where's the technical problem in the washing machine? You won't sit down, or at least I probably won't sit down and ask a career coach questions from my washing machine, where you would need a bigger model that can maybe answer more complex tasks. And the same is with, for instance, lighting, right? You just need a simple language command like turn on the light, turn them off, make them brighter, and so on. And there are a lot of use cases when you think around where now a lot of those vendors start just implementing the big models, but with this technology, they can then use the much smaller ones and still meet the needs of the customer. And this really has big benefits, right? Because with what you can see, a 0.3 watt hour is what is used from ChatGPT to deliver response. With the PSOC edge, where this is the Infineon hardware, plus a small language model on the edge, we are at 0.007 watt hours. So this is 98% energy savings with this technology. So let me come to the last point, still very important for us. We use AI. This is when we use AI basically in all our processes. So we use AI in our go-to-market and customer support, understand customer requirements, tailored offerings, support and assist customers. We use it in digital products and services where we enable new value features, improve efficiency and lifetime, reduce development time. In R&D, research and development, speed up and automate development processes, focus on human intelligence and meaningful tasks, and increase time to market. And then also, of course, in manufacturing and supply chain, where we increase yield and equipment efficiency, optimize capacity, material utilization, and deliver a customer's need. So Infineon is a tech company, so of course there are a lot of tech people that love to build AI systems. So we have a lot of AI use cases. I think we have, by the real registered one, over 300 now, different AI use cases that we produce internally. And of course, this also takes energy. And especially if you look at manufacturing, not the AI system takes energy, but general the manufacturing processes that we have are quite energy and resource intensive. I'm not sure if you have ever been to a site or inside a hall where a site where semiconductors have been manufactured, but it's complex processes with sometimes 70 stages of a process just to get to like one next step. It's a really super complex process that takes energy. It also takes a lot of resources, gases, chemicals. And if you use AI to improve those processes and process steps, only focusing on energy, there's a number from McKinsey, you can save 20 to 30% of potential energy savings in semiconductor manufacturing. And then there's a lot more if you really look also to resources and so on. And so these are, for instance, direct savings. It's process optimization where you can directly feel the savings. It's predictive maintenance. So I'm not pretty sure, probably you've heard about this word predictive maintenance. Usually what in a maintenance schedule, what happens, you have a certain time frame, whatever, a year, sometimes less, sometimes just a month. This is when a machine has to be then maintained again. Spare parts are exchanged on a regular basis just because you know that most of the time, again, rough estimation, this machine will break down. And of course, sometimes it happens that this machine could last much longer, or it breaks down much more before. If it breaks down much more before, you have a real problem because you have downtime. If it lasts much longer, you have exchanged a part where you didn't need. And of course, this changing of a part is not only costful, but it is also like it's a resource. It takes energy, it takes resources to produce these spare parts. So of course, we would like to not exchange them when it's not needed. And there's where predictive maintenance is really, really important now, where the AI can help us predict based on, data of these machines, if likely in the upcoming time the machine will break down and should be maintained or not. And this really helps down also to decrease the number of spare parts we need to exchange and save energy. And then there's an element that's a little maybe less direct, but still relevant. This is HVAC and facility level, where AI can also help save a lot of energy. And this is a concrete example that I would like to go a little bit more in depth. It's AI-powered energy optimizer. This is a use case that we use ourselves internally. We also bring this to our customers. And don't worry, I'm not going to try to walk you through the details here. Simply speaking, what we did here is an air handling optimizer, a water side optimizer, and especially if it's used with humans around, there has to be also a human comfort optimizer, because yes, you can optimize a lot, but you still want to feel comfortable if there's an HVAC system automatically changed to your needs. So what is doing again, it basically predicts, in this example, thermal comfort, right? Before, if you look at this blue line, this would have to be quite big because you think, I don't know where the comfort level is, just to be safe, increase the range, which then costs more energy, just to make sure that the humans feel comfortable. But if you can really predict what is the thermal comfort level, then you can really decrease this range and save energy. And this you can also adjust over time to make sure that the people who work in this office really feel comfortable. Yeah, that's it. And again, with this, the potential saving of commercial industrial HVAC is 500 terawatt hours. So this is quite a big number, and this is what we are going for in our own facilities, but also with our customers. So now you might say, this is maybe a great marketing show that she's putting us here. I mean, AI systems do take energy. There are sort of other also social sustainable problems with AI. How do we know that the systems at Infineon actually do perform to this measurements? And then what we did here is a couple of years ago already, and now it comes really to my field of responsible AI. We published the Manifesto of Responsible AI, where we published high-level values. Just because this is also what goes to externally. Those were values such as responsible and transparent use of AI, human-centric AI, safety and security, AI for privacy and data protection, sustainability. Not all companies have sustainability as their core value. We at Infineon do have this. And inclusion. Again, could be nice marketing, right? Values, what do values do with a company? I mean, who actually really follows values? Well, I mean, they do have an impact, I think, but of course, if you really want to make them work, you need a governance framework. And this is what we did at the Responsible AI Office. We actually rolled out a governance framework that ensures that all the systems that we produce and procure, at least the ones we know about, go through a certain process. It starts with an AI risk classification, where we look at what are the particular risks of this use cases. What could happen if something goes wrong? And we use our values, or at a more technical formalization, our values to also make sure that we don't forget a certain risk, for instance, sustainability risks. This is then followed by what we call the responsible and trustworthy AI management, where we give clear requirements that are needed to mitigate those risks. So those could be bias requirements, it could be accuracy, robustness, also sustainability requirements that a use case has to perform. And especially when the systems are high risk, we will have a very, very detailed final check to make sure before this is released either to the market externally or internally to our employees, it is responsible and trustworthy. And we will also make sure that it's monitored afterwards, because we all know that AI systems can drift, they can change over time, and we want to make sure that this is not happening. So I know I'm already over time, but just the key summaries. Powering AI, 22 million metric tons of CO2 yearly could be saved by using Infineon products in all data centers worldwide. Enabling AI, small language models at the edge can save up to 98% of energy. And using AI can not only make companies work more efficiently, which everybody talks about now, but also helps save significant energy and resources. And with this, thank you very much.
Thank you. It was so fun to listen to you.
Great.
Does anybody else have questions? Because I do, but my questions aren't nearly as important as your questions are. So if you have a question, raise your hand or scream. Ah. Can you also scream?
Hello, thank you very much for the talk.
Hello.
I just wanted to know if Infineon as well uses neuromorphic computing or does any research in that way?
We have research projects in this area, yes, because we do see this as a potential relevant field for the future.
There was also another hand. Oh, so many hands.
Thank you very much for this very interesting talk. You said that the chips are very specialized. And my question is it possible to adjust the chips at a later time if the tasks the chips need to be able to do change at a later time? And my second question would be, how repairable are the chips? Is it always necessary to place a new chip, or is it possible to do repairs?
So usually it really depends. I mean, I think it depends on the software stack also on top of this. I mean, now we focus also on AGI, these AI models, because they are smaller, usually designed for one specific task only, right? And the underlying chips as well. So I'm not from the hardware section, so I wouldn't be able to go into detail to tell you about the chips itself. And so usually what we do is there is no kind of retraining or really adaptation while this is live. Mostly also because a lot of those models that we use are, for instance, in automotive or in industry. So you do want to make sure that they're reliable and that you don't want to actually have some changes without really proper retraining. Repairable, most of the time they have a certain lifetime and a life cycle. The chips that we produce are designed to last extremely long, especially when they're used in industry. But then eventually you would have to recycle them, or you'd have to kind of throw them away earlier. What we have done, we have project that we have a degradable platen underneath that can dissolve in water, which then allows you to recycle some of the kind of elements that are on the chip. That at least you can't repair it, but at least you can recycle the chip. It's with a startup called Jiva. If you're interested, it's a really cool startup. I mean, they help us doing that. I'm really impressed about their ideas.
Okay, hello. I have one very simple question. You have mentioned that you have been developing the policy around AI. And I wanted to ask you what was the biggest challenge deploying those policies, and would there be a need in the future to elaborate on those policies eventually?
So I understood what is the biggest challenge around the policy around the AI, and the second one?
And would there be a need to elaborate more on those policies so that you can adapt them for the purpose of sustainability?
Yeah. So they are more sustainable for sustainability, you specifically asked? Okay, yeah, okay. So, I mean, I think the main policy around AI is the EU AI Act. And while I do think it's actually quite easy to get the high-level part of it, and it's actually quite comprehensive to understand what is high risk and what is not, and so on, it is quite challenging to really understand, if you have a high-risk system, what exactly do you need to do? I mean, the AI Act works with similar principles like we do. It has to be, for instance, bias-free or robust or whatever. But then the question is always, but when is good enough? When are we actually at a level that is good? And how I perceive the industry, and I'm in touch with a lot of people in the field, including some of the certifying bodies, there is no clear decision yet. There is the kind of nobody really knows exactly how this is going to play out. And this is, of course, extremely difficult for companies. I mean, in Infineon, we can maybe afford, we have kind of made our own assumption what we believe it's going to be, and this is what we're going to follow for now. And once the standards are out there, which are delayed, we then know a little more. But even if the standards are out there, I'm pretty sure there will still be a lot of kind of open spaces. But I see this extremely difficult for startups and smaller companies who cannot afford to look into this in depth. And then, I mean, yes, I mean, they will have to be updated for sure. Sustainability in the ecological sense actually is not in the EU AI Act. Its focus is, it's on a voluntary basis. It is there, and there is some tracking for bigger models that is asked, but I think to really push companies into tracking the AI system, seeing how much energy it takes, and then applying mitigation measurements to make them smaller or use less energy is not in the EU AI Act. And if we look from this perspective, it would be. It would also mean a lot of documentation for companies if this has to be proven to the government, which, of course, it's always a challenge at the same time.
Thank you so much for your wonderful keynote and the answering of the questions. And I see that there are still a few hands and questions in the audience. We don't have time to answer them here, but you will be there to answer them off stage. Perfect. A big applause again for you.